And I think we are live. Hey, Christian, how
It
you doing,
feels like
buddy?
it. It feels live right now. I am doing well, weathering the craziness. As you can see, I've stocked up on books to read.
On books, right? So
um,
you do know that alcohol has to be over 60% proof, or 60% alcohol in order to kill germs and viruses, right?
I have a few of those back there.
Nice,
120 proof. Yeah. Yeah, no, I'm prepared. I'm prepared.
awesome. Well, I just want to welcome everybody who's just tuning in, and welcome back if you kind of watched the show before. But what we're going to kind of concentrate on and take a look at today is something kind of, I would say, bleeding edge, but something very, 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 very cool. So there is a new feature in Envoy which allows WebAssembly modules to be loaded dynamically into the hot path of the filters, right? And and why is this exciting? Well, I think it's really exciting because being able to extend the functionality of Envoy is, well, I mean, it's pretty limitless. You can do simple stuff like just being able to manipulate requests, adding headers, or you can do really, really cool stuff. You could do request validation. You could do checking for SQL injection potentially in a request. You could do sophisticated authorization on a user level, which is kind of, it gives you the capability to devolve even more of that logic into a sort of a more, I like to see it as like a platform centric way. And let me just switch over
Which,
to,
oh yeah, go ahead. Switch over. Which I was just going to add is really important and is becoming even more important because as we see people adopting Envoy-based technologies like Solo, we have Gloo, which is our API gateway built on Envoy. HashiCorp, we all have Consul Service Mesh, a service open source service mesh built on Envoy. What we end up seeing is Envoy is amazing. Envoy has a lot of features out of the box, but this new technology, when we bring it into existing enterprise organizations, there's a lot of assumptions and constraints in those organizations
right.
which might not be present in the open source at Wild or Google or Lyft or where some of these technologies may have originated. And what they need is a way to customize and be backward compatible with some of the things that they're already doing. And just like you were saying, Nick, the ability to extend Envoy now to change its behavior is in a little bit more approachable way
Yeah.
is very powerful.
So some of the naysayers, I think, may look at this and go, "Oh, is the service mesh becoming the enterprise service bus?" And
Mm.
I'm going to put my cards on the table. I don't actually think an enterprise service bus was a terrible thing. I used one and quite enjoyed using it. But I guess, is there too much information or too much logic going into the service mesh? What's your
Mm-hmm.
opinion on that?
So that's a great question. I think that, and I spent a lot of time working on technology in the integration space and service or enterprise service bus space. I think one of the big drawbacks of the enterprise service bus that from a technology standpoint, when it originated, sounded amazing, right? And maybe we're going through the same thing with the service mesh right now, but I think with the enterprise service bus, it was more the processes that built up around it and the ownership of the actual service implementations, which started to bleed into the service bus, is what
Right,
got things into trouble. I think what we're and it was highly centralized, right? I think even
right,
the creator of WebSphere, he at IBM, he said he created that WebSphere. Creating it the way that he did was a big mistake because it just forced everything through this. It was like building a castle, right? And you had to go through that castle to get what you wanted. I think what we're doing here in general, and where Service Mesh solves these communication challenges, in a highly decentralized way,
Yeah.
and where workflows can be built in a decentralized way, I think we allow teams to own their config, their parts of the service that they need without having to try to centralize all of that
So
stuff.
we could have filters which were application team centric.
Yeah.
That they're still kind of deployed globally. It's not that you have to embed this sort of same code into a number of common services. You can deploy it into the service mesh, but the opportunity is there for the individual teams to own those filters, to own that code, and to be able to deal with that. So I'm pretty excited about this. I think this is going to be incredibly great piece of technology. Very excited to see this come down the line. I love the fact that it's also very portable. So there's no kind of sort of definition on it must be made in C++ or Go. It's sort of, because it's WebAssembly, it's anything that can compile WebAssembly modules, which is exciting. And today we're going to kind of take a quick look at this, but I think if folks want to, and if folks want to see kind of some more stuff, we can kind of continue working through these examples and kind of iterating over this. So give me the 101, Christian. Explain to me what you're doing with WebAssembly Hub and kind of this process flow. Where does this filter sit inside of the Envoy proxy?
Yes. Okay. That's a great question. Let's also set a little bit of context, right? So WebAssembly was built originally for speeding up applications in the web browser, and doing that in a way that extended to be able to write these applications in languages other than, let's say, JavaScript, and to run it dynamically in the browser in a safe, sandboxed way.
Right.
And to be able to dynamically bring that down to the browser, just like a web page, and run it. And so what we're doing is we're taking that same model and bringing that to something like Envoy, wherein the browser, you would typically write in CSS and JavaScript. In Envoy, if you wanted to extend Envoy, you would have to write in C++ and compile it and statically link that into the Envoy binary.
Well, I think there's a bigger sort of problem around that as well, which is if you kind of want to create functionality which is bespoke to your organization, you've got to get that upstreamed. You've either got to fork Envoy, or you've got to try and persuade the Envoy governance committee that your change is beneficial to the rest of the world. And actually, I think one of the things I love about the WebAssembly filters is you can write functionality which is very bespoke to your organization, and not have to kind of deal with any of that. You can create that very, very unique functionality. That's very nice.
Yeah, exactly. And even if you did fork it Envoy and run your own custom Envoy, so first of all, now you're on a fork. Now you have to deal with that, right? But then the second thing is, for all of your extensions that you create, whenever you deploy Envoy, all of those extensions that you create, which might be applicable to team A, some of them for team A, some of them for team B, and so forth, the binary Envoy, the binary that you use in that case, will have all of the things, right? So you end up with a more bloated, over-resourced Envoy to deal with things that might only be specific to certain teams. And so what the community has been doing, the Envoy community, Google has led a lot of this in terms of getting the WebAssembly VMs into Envoy, and kind of or creating the abstract programming interface, or they're calling it abstract binary interface, in place, so that eventually this will get into upstream Envoy. And this will be in the main line on master.
And I do want to put a big disclaimer on some of the things that certainly some of the integrations around Console is very, very experimental. We're kind of just looking around this, but I want to get people to get a feel for things. Some of the stuff you're doing, obviously the WebAssembly Hub is getting quite mature and things like that, but when are we going to see this in Envoy? Are we going to see 1.14 or 1.15 maybe, or maybe later on than that?
Yeah, probably pretty soon.
Okay.
I would say that, for example, so Gloo, our API gateway, we ship you can install Gloo with WebAssembly enabled.
Right.
Istio just announced 1.5. Their service mesh has WebAssembly enabled. So as you know, things mature, of course, there will be an upstream Envoy, and that'll be pretty soon, and then we'll be able to take full advantage of this across the board, across any frameworks using Envoy.
And if folks are interested in following the progress, the sort of the Envoy WASM, which is kind of an internal fork on Envoy, this is where all of that work's happening, isn't it? And it's getting regular commits. I've just got that up on my screen there.
There we go. You should be able to see that right here. So this is the fork of Envoy that is maintained to add the WASM support, and is what things like Gloo would be using.
Excellent.
Under the covers.
And when I looked into this, it literally is. I mean, the kind of the rules around Envoy is that anything that hits Envoy master is good to ship. I mean, they have they take that approach on the master branch. The kind of the Envoy WASM stuff, which is going into Gloo, and some of the experimental proxy that I've been playing around with as well, is based off Envoy 1.13.0. So it's a pretty recent release, like 1.13.1, I think, is the latest sort of patch release on Envoy. So that's pretty nice.
And so if you look at the slide here, just real quick, the way that you would extend Envoy, like we mentioned, is through statically linking in your changes. But with WebAssembly, what we can do is dynamically load. So we can send that to the proxy and dynamically load that those behaviors that we want to inject into the proxy.
Excellent.
And then, so what we've been doing at Solo is we've been kind of focused on the experience around how you build these WebAssembly modules, how you package them, how you ship them, how you socialize them, and then ultimately how you consume them and deploy them into your Envoy-based frameworks.
Are you up for a challenge?
Yeah, what's up?
Do you think you can show me? Do you think we?
I think I can.
I can do this live.
I think I can. Let's come over here. So what we've been working on is the WebAssembly Hub.
Okay.
That's kind of the registry for discovering WebAssembly modules, and alongside the WebAssembly Hub, we have some tooling to help developers get started with building WebAssembly modules. So if you click on docs here in the WebAssembly Hub, we'll be taken to the docs where if you click on installation, we can get the actual CLI to begin our efforts here with WebAssembly. One thing I want to point out is that this tool is intended to simplify all the pieces that you need to get into place to get this working, all the tool chains, setting up the correct versions of dependencies, and so forth. So let me actually show you that right now.
I got a better idea.
Go for it.
I'm going to just do it.
Okay.
Yeah, we will. We'll share all of the links and all of the slides, but let's just run with this. This is
okay.
gonna.
Where's your screen? How do I see your screen?
Oh, you can't see my screen.
Yeah.
It's private. There's a bit of a flaw in my logic here. I think maybe you show this bit, and maybe I'll show some of the bits later on. Okay.
All right. So this is what we'll do. From my screen, you should be able to see my screen. We have WASM installed here, and what we're going to do is actually, if you know the way that I like to do demos, I'm not a very good typer in front of live audience, so I try to script them as much as I can. And so the first thing that we're going to do is run WASM init. And when we run WASM init, that will allow us to choose what type of project, what type of WebAssembly language that we want to use for it, and then the platform to target, and so forth. Right now, we can choose between C++ and assembly script, which is a variant of TypeScript. And Rust is actually very close to landing. I expect that very soon.
Yeah.
And then if we come over here and look at, I have another, over here.
And for folks who are watching, sort of with the language, you do also need an SDK which allows you to integrate. Go supports WebAssembly, and you can compile to WebAssembly with Go. The SDK, which allows you to develop the Envoy plugins for WebAssembly, is in work in progress. But
yes, that's correct. And so just in general, so with that in mind, in general, the languages that are supporting WebAssembly can be found here with various levels of stability and so forth.
And I think as well, the key thing around the SDKs is you can build your own SDK. So if you want to put the effort in and develop a brain thing SDK, you could do that.
Here's a repo for some of the existing efforts around writing the SDKs for specifically for Envoy for these different languages, and that's gonna continue.
Excellent.
So right now we have a couple different options. We're going to choose assembly script. C++. I mean, if you're going to extend Envoy today, that's how you would do it with C++. We're going to pick assembly script. We're going to target a particular version of Envoy that supports WebAssembly modules, and that's what we would find in these platforms. And there we go, WASM init. And if I come over here to my
and just for anybody who's watching and going, where's Consul on the list there? We are working on getting that integration in there. Yeah. So
definitely.
Coming very, very soon.
So if we go to filter, where we just created our filter and do a listing here, we see we have automatically generated some metadata files, which we'll take a look at in a second, and as well as the source code. Actually, let's open the project right now. You should be able to see that. Thank you for the welcoming. And what we've created is the package.json, which brings in the correct runtimes to be able to bind to the Envoy APIs or ABIs. We have a runtime config, which also binds in the correct versions or targets the correct versions. And then under assembly, we see the source code.
Okay.
So if we come in here, we can see the source code for the extension or the module that we can write that will fit in nicely with the way Envoy loads and expects to call into the various functions here or methods here. And we can see that this one is fairly simple. What we can do with some of the out-of-the-box example here is adding, for example, headers to the requests or to the response. Right now, there's not body support, but that should be coming. And this will give you a lot of power in terms of dealing with certain security protocols, maybe doing certain types of request transformation or mediation, and so forth. You can do that in your own code in the language that you prefer, like this.
And because this is just TypeScript, I can import any module from the sort of the NPM sphere and use those. So I'll be able to do things like making external calls to servers.
As long as everything that gets compiled down into the WebAssembly, you basically have all the implementation, all the functions and everything that you need to do within the WebAssembly module. Because when you deploy into WebAssembly, you can't reach out of that sandbox. You can only get what Envoy allows you to get out.
So we have to build something statically linked.
Yes. So everything needs to be compiled into that WebAssembly module.
Okay.
But so in this case, we'll just go with the out of the box sample here. We're adding headers, But if there's a configuration, then we'll add a header with a dynamic configuration. And so let's take a look at that. First thing we need to do is get the build chain in order and build our WebAssembly module. The tooling here, WASME build, allows us to kind of have the same experience that we would have if we're dealing with Docker images.
Yeah.
Right. So these are just basically tarballs, right? And here we're building the assembly script. We'll give it a name. We'll give it a tag, filter demo v01, and it should take a few moments, not too long. Okay, I'm along.
Blame Node.
Yeah, what's that?
Blame Node.
Yes, always.
But this is
we'll
really
give
cool.
that a second to build, but yeah. But you can see I didn't have to go pull down libraries and mismatch on versions, and so I just init, add my code, all the stuff that I need to worry about, and then build. And we can see here now that it's done. It's built it into this this image.
And this is
now if I do WASME list.
This is an OCI container image, right?
Exactly. So it's built as an OCI container image. And when we do WASME list, we can see that our new module got built and lives locally. And if you want to see a little bit more detail about where that lives, oh, come on, TMX. There we go. Under WASME store, we can see where all of the images live. And if we want to look at a particular one, 38, let's say, we can see in here we have the WASM module itself.
Yep.
We have a descriptor about that module, and we have a runtime config, which is part of a WebAssembly for Envoy spec that we've been working on, just metadata that describes all of the versions and all of the things that are necessary to be able to run this particular module. So from here, what we can do is push our module up to the WebAssembly Hub. Oh, I guess I didn't log in. Try that again. Let me log in. See if I can remember this.
Oh, is it going to do the stars? Oh, you're lucky.
Me. There we go.
Password 1, 2, 3.
Now if
So I like this. I like the fact that the tooling is there to kind of make things easy, gets people up and running really
exactly.
quickly.
Now let's cross our fingers. Pushing it. Oh, not. Okay. All right. Well, maybe there's
I know exactly what is going on here.
Yeah.
Schools are closed, aren't they?
Yeah, they're closed. Everyone's home. Everyone's
playing Fortnite, killing the bandwidth.
Well, assume that if we had pushed that correctly, I'll come over here to WebAssembly Hub.
Just a quick question for you, just to interrupt you there. Around the performance, what's the performance going to be like as opposed to obviously the native C++?
Native is going to be faster.
Okay.
Native will be faster. There is a performance penalty jumping into the WebAssembly VM. Yep. And then once it's in the VM, I think we're seeing, so this is completely anecdotal, 70 to 80% of native native speeds.
I mean, that's pretty good.
So it won't be exactly, like I said, it's anecdotal. Improvements are happening every day.
The way I look at this as well is that what I'm doing with a lot of what I want to do with a lot of my WebAssembly filters is I want to move code from my application services and I want to put it out into the proxy. So I want to kind of platformize a lot of my code. So yeah, I might not get the same performance as native C++, but I'm probably going to get comparable performance if that code was living in my application.
Absolutely, yes.
And
especially
maybe
some of our big enterprises, maybe even better, exactly. Maybe so for example, I know a lot of enterprise folks building services are building them in Java and so forth. definitely there could be performance gains in that arena.
And I think the nice thing to mention as well is that this is entirely optional. You do not
Yes.
have to put the web filter in every single sidecar
Right.
inside of your estate. You can pick and choose. If you have very, very performant requirements for service communication, then maybe you forgo WebAssembly. But if you find that it's okay,
then you forego. You might be finding yourself in situations where you forego the sidecar proxy altogether.
Right.
Which is why I like Consul Service Mesh has the ability or offers the option to use native integration with actual native libraries to integrate with the service mesh.
Yeah, you can go.
And that's something that Envoy is kind of pushing as well. There's a universal data plane API that folks are working on to extend the capabilities of Envoy-like control planes down into the actual application native language.
Interesting.
Like a gRPC or the language code itself and so forth.
If you need that ultra performance?
If you need it, exactly.
Right.
Exactly. Right, so let's ignore that one for a second. But once we've pushed it or once we've built it, then we want to test it, we want to run it inside of Envoy. So if we do WASM list, we see that we have our filter, our module here locally. What we're going to do is on the top pane here, you're going to see I'm going to do WASM deploy Envoy.
Yeah. So
I'm going to take my module, I'm going to deploy it into Envoy, and we're going to run that, in this case, locally.
So what I like about the workflow here is the workflow is actually quite nice for a developer working on a filter. You don't have to compile, put it somewhere, deploy it into your service mesh, go through the whole testing process in order to be able to kind of just get some fast feedback. And of course, you can unit test things and things like that. But
yeah, and at Solo, actually, we're working on a virtual environment that will virtualize Envoy and allow you to debug into it without, exactly like you said, deploying it into service mesh and all that stuff, where things become a little bit more difficult.
Excellent.
But so we can see that Envoy has started up. The WASM VM has been loaded. And we should also see.
Yeah, I can see the filters loaded there. Add header.
Yeah. Oh, there we go. Yep. So then on the bottom, if we call into our locally running Envoy, what we should see is our new header, hello.
Nice.
And the config that we passed in, if we come back up here to the top, the config that we passed in here is demo friends, and that's what we see as the header here.
Well, let me have a try. There's plenty of folks who's going to be going, that Christian, it's all about smoke and mirrors. There is no smoke sometimes. Yeah, sometimes. But I think one of the things that I really like this workflow. It's really kind of simple, straightforward. It gives you the ability to kind of do all of the things extension that you may not even know about. One of the things that I want to show folks, which I've just got on my screen here, is this is actually the Envoy configuration or something very similar to what you were running. So if you look at it in terms of context of Envoy, if you're familiar with it, you can see that Envoy has a concept of filter chains, various different filters such as TCP proxy, various different sort of database protocols and things like that. So, layer 7 aware things as well. And we're using the HTTP connection manager because it's just HTTP. So I've just got some simple routes here where the filter sits is here in the HTTP filters section of that configuration. So before the request flows through Envoy and gets routed out to the upstream cluster or wherever, the local cluster, wherever it's going to go, it's going to hit this filter and it's going to get processed. So I could theoretically stop this in the request path, which I think is pretty cool. So I've got a very similar example to what you have here, and let me just get this up and running in Consul Service Mesh. Again, massive caveat. experimental. Here be dragons, but it's really interesting, I think, to see just this stuff working. So let me just run my environment, and I will share the repo so you can play around with this on your own. But what I'm doing is I'm basically just running Consul Service Mesh inside of Docker, and I'm going to start a couple of application services. This will take about 10 seconds to spin up. There we go. And we're good. So, of course, I'd opened up in the wrong browser window, but let me just open up here, localhost 8500. We can see here's the console UI, and I've got a web service, and I have an API service, which is both using the sort of the Consul Service Mesh. Web has an upstream dependency on API, so web will call API. Let me just open up my docs there. So we've kind of discussed this process here. This is kind of like what it's going to look like in terms of the Envoy filter. You generally don't need to worry about that. How things will work in terms of how you configure console, well, you know, that's kind of open for somewhat discussion right now. As I say, experimental stuff, but the sort of the process will be as you would expect it. It will be easy in the sense that you can set it in terms of configuration, either through some sort of centralized configuration or probably through a service registration. Again, experimental. This is not destined for production just yet. But I have that web service, and the web service has an upstream on API. API is going to use a WASM filter in the hot path. So in the request path, the proxy will receive a request from web. It's going to pass through Envoy. Envoy is going to process it through this WASM filter, the same one as we've got here. And then that's going to end up in, well, maybe somewhere. Let's see if it's going to work. So everything's up and running. So I'm going to curl my endpoint, local host, and I think it's 1990. I guess we'll find out that soon enough.
Find out, yeah.
And well, that seems to be working. So what I can see here is, there we go. So I've got the HTTP headers, which have come from the upstream API service there. And you can see there that I've added a header called hellos, and it has a value of world. So just to show you a little bit around that further, I'm just going to log into the API directly, and we can just take a look that if I manually hit that endpoint. So if I'm just going to curl localhost 1990, and you can see there is no header because that's actually hitting the destination service. If I just manually sort of bounce in and call that through the upstream exposed address, which is localhost 9091. Whoops. And again, you can see there we go. So we've got that hellos and that world. So you can just see the difference there. There's the original request, which hasn't been, it hasn't mutated, hasn't passed through Envoy. So there's no header on there. And then this one, which does have that header. So I'm all about kind of just proving that this is deployable and how this works. So let's just quickly make some changes and just kind of test out that workflow. So I am going to say, what am I going to say? What am I going to say? I have no idea. I'm just going to say hello. And what I'm going to say is you.
I trust you. I can't see your screen, but I trust you.
Oh, yeah, you can't see my screen. Yeah. I'm just going to say hello, YouTube. So I'm going to save that file. And I'm going to bounce over. And what I have here is just a terminal into the build folder. So I'm not going to use the WASM Docker build, but I'm using your build container here, and I'm just going to do an npm install, and that's working great.
But for folks watching, use WASME.
Oh yeah, use WASME, yeah, for sure. But I'm just I'm cutting the corners here so I don't have to push anything.
Yeah.
And then I can do that build. So that build is exactly the same as what we saw earlier on, which I think is it's incredibly quick, and it's sort of incredibly sort of easy. So let me again. I'm just going to roll that API container and start a new one, so that it will pick up the new filter, and it'll get loaded into Envoy. We can see that has come up, and then I can curl that endpoint there. So now we can see there, if you look there, hello YouTube. So that change, I've just literally changed that WASM filter. I've just gone through a simple deployment process. I've played the role of the CI system, but yeah, I'm impressed. That's relatively easy. I mean, it's not relatively easy. It's very, very easy to work. And so what do folks want to see? I mean, I think this is interesting, something to play around with. I'm interested to look at the types of things that we can do with this, and some of the sort of the more sort of procedural elements, like building this out, and how do you manage this in production? How do you what is the workflow for developing this stuff? If folks would like to see some more around this, and like to see sort of some more in-depth tutorials, then put some comments down there and below, or just ping us up on Twitter or wherever, and we can dig into this.
Yeah, definitely. Let's keep this series going. There's lots of stuff to dig into here.
This stuff's coming like really thick and fast. I mean, sort of, when will this be ready for production? Like months, like literally just a sort of very, very soon, which is coming fast.
It's coming fast.
Incredibly exciting.
It's impacting and bringing more functionality and more integrations. And once people start building modules and sharing them and so forth, it's gonna be pretty powerful stuff.
And that's I just want to I think that's worth a mention as well. So like one of the concepts around using the WebAssembly Hub and kind of working through that entire process is that I can actually create an extension which is useful for me. It might be let's say a JSON validation, and I can share this in WebAssembly Hub. Somebody can use it. They can pull my code. Maybe I write a SQL injection sniffer in the for the request validation. Really, really useful things there.
Yeah, definitely.
But I hope this has been interesting, and I hope you like this stuff. I will share all of the links in the video description below, just as soon as we drop off this call, to the things. You can kind of start playing around with this now. Again, here be dragons, experimental, but I think we can all get excited about what is coming very, very soon.
Yep.
Christian,
I'm excited for the next series, the next episodes.
Oh, you know what I want to build?
What's that?
I kind of I'm intrigued to look at some sort of and I don't know if this is possible, but I'm intrigued to look at how I can do some things like JWT validation. Can I move my JWT validation, which a JOT is obviously a cryptographically signed document, as long as you validate it correctly. If you don't, you could potentially open yourself up to all manner of sort of spoofing and things. And when you look at some of the sort of the recommendation around OWASP and security and some of the sort of the criticisms that JWT or JOT has had, a lot of that is centered around the fact that the spec is so open that you can actually shoot yourself in the foot.
Yeah.
I'm interested to see if you could build a global WASM filter, which would just handle that JWT, taking all of that stress and pressure off the engineering teams and just kind of putting that as a centralized platform component. I'm also interested in seeing is whether we can kind of chain those things right the way through, from maybe looking at Gloo API Gateway and OpenID Connect and things. Is that possible?
Let's dig into it, and we'll report back in the next episode.
Fantastic. So again, thank you all for watching. if you like this kind of series, please like and subscribe there. Please leave us some comments if you don't, because we want to make this better. We want to make this good for everybody. And
Absolutely.
we'll be back next time. I hope everybody has an absolutely fantastic day. Christian, again, as always, thank you so much.
Thank you. And you have a good evening.
Thanks. And we're done. Later.